Hello again, Precalculus 12, and today we're going to be doing our last function graph here, which is the tangent function. And again, we did briefly look at this in chapter 4, but we didn't go through how it's created, so we're going to do that today. And I'm going to teach you a couple of sort of tricks I use to figure out how to graph this thing. This one you will not see as often as you see sine and cosine, but it is good for you to know what it looks like. So if we go back to our quadrant system, again, a reminder that we had some special values of tangent on all these axis lines. So if we were on the positive x-axis, we know that tangent of x was equal to 0, and that's because we know that tangent of any angle is equal to opposite over adjacent. Or if I were to draw myself in a triangle, my opposite would be y, my adjacent would be x, so tangent is also y over x. And on the positive x-axis, you would have an x value, but your y value would be 0. You get 0 over x, which gives us 0. So this could be tangent of 0 is 0. This could be tangent of 2 pi is 0, etc. Okay, so every time we go around the circle and end up on that positive x-axis, we get tangent to 0. This will also happen on the negative x-axis because y is still 0 over here. So tangent is also 0 on the negative x-axis. So this would be something like tangent of pi or 3 pi if I went around an entire circle, etc. We also had, if we were on the y-axis, that means y has a value, but x does not. And if I end up with 0 on the bottom of my denominator, that's not possible. So that means that on these axes, we actually have that tangent does not exist. So this would be, for example, tangent of 3 pi over 2 does not exist. And if you plug that into your calculator, you'll get error. You plug tangent of 3 pi over 2 into your calculator, you'll get error. Also on the positive y-axis, again, x is 0, so you get y over 0, which does not exist. So for example, this might be tangent of pi over 2. Okay. Also a reminder from CAST, we have that tangent is positive in quadrant 1 and quadrant 3, and negative in quadrants 2 and quadrant 4. And so what that means is that if we were to travel around our quadrant system, if we travel from the positive x-axis where our angle is 0, our tangent would be positive and then not exist, then negative, then 0, positive again, not exist, negative. 0, positive, not exist, negative. 0, positive, not exist, negative. And it goes in this cycle. So if I have something that does not exist, just a reminder that that's an asymptote. So we're going to draw those on our graph here. And our asymptotes are going to go over by 3 boxes. We can go to the left and to the right of the origin. And that means that the span, the distance between our 2 asymptotes is 6 boxes. So our next asymptote needs to go another 6 boxes over. And then 6 again. And we can keep going. Okay. And our actual graph, we have that tangent is 0 when x is 0, so that's at the origin. Then we know that tangent is positive in quadrant 1, so if I'm moving to the right along my axis on my graph here, I'm going to be positive, and then I have my does not exist, then I'm going to be negative, then I'm 0 again at pi. Then I'm positive, does not exist, negative, 0 again when I finish a full circle at 2 pi and at 3 pi. So that means that my 6 boxes is pi units. Okay, because between each of my blue dots here, I have 6 boxes, and I went from 0 to pi to 2 pi to 3 pi. So 6 boxes in my graph here is pi units. Okay. Now we're going to use the fact that we know where tangent is positive and negative to actually draw in our curve here. And one special value that's nice and easy for us to draw is we know, for example, if I have a triangle, I have one where I have 1 root 2, and therefore tangent is equal to 1 over 1, and that is for pi over 4. So if I put a point on my graph that is at an angle of pi over 4, it would have a y value of 1. Now, it might be helpful for us to label our asymptotes here so that we know where they are. And if I take a look back up at my quadrant system, I know that tangent did not exist at pi over 2, then 3 pi over 2. The next one would be 5 pi over 2, etc. So this one here is pi over 2, our first one. Our second one is at 3 pi over 2. Our next one would be at 5 pi over 2. That last one we drew in here would be at 7 pi over 2. So I know that pi over 4 is halfway between 0 and pi over 2. Pi over 4 will be here. And so that's going to help us with our 1 point. So we're going to have a point with a y value of 1 and an x value of pi over 4. And this will happen on every single cycle. Halfway between the center point and the asymptote to the right, halfway between there, you will have a point at y equals 1. If we think about the negative quadrants, if we put this same triangle that we just drew in one of the negative quadrants, tangent would be negative 1. So halfway between the center point and the left asymptote, we are going to have a point where y is negative 1. And so we're going to draw that in. Halfway between the center point and the asymptote at a y value of negative 1. Now, these look like if we connect them, they would be a straight line, but they're not. It's a curve, similar to how sine and cosine were curves. So I'm going to connect these in sort of a flowing pattern here. And I'm going to label this left asymptote that I didn't label here. This would be negative pi over 2, the one to the left of the origin. So you'll notice that from asymptote to asymptote, there's a span of pi. That is our period. Okay. And that's because we notice that we only have to travel a half circle on our quadrant system before we get back to the same value. And we did that in chapter 4. We saw that cosine and sine have periods of 2 pi, but tangent has a period of pi. Our zeros, or our x-intercepts, are at x equals 0, pi, 2 pi, etc., or x equals pi n, where n is an integer. So remember, that means that if n was negative 1, we would have a 0 at negative pi. And that just means we would have gone to the left of the x-axis. We can see that our domain has restrictions. We can't have anywhere we have an asymptote as an x value. So x cannot equal pi over 2, 3 pi over 2, 5 pi over 2, etc. All those asymptotes. So those are all the y-axis values on our quadrant system. And we can write this in a more neat way, similar to how we wrote the zeros. And this is saying that x can't equal pi over 2 plus pi n. And we can see that because to go from the first asymptote to the next one, we had to add pi. And then we had to add pi again. So we're adding half circles each time from the first one. and again, n is an integer. Our range, you can see from the graph, it goes up forever and down forever. So our range is all real numbers. And our vertical asymptotes, well, we just said that on the domain. So instead of saying x can't equal, this is the equation of the asymptote. So we're going to write x does equal pi over 2 plus pi n, where n is an integer. So I find it easiest to first figure out where the center of the first curve goes. So the center of my first curve here is at the origin. And the only thing that will move that center point is moving left, right, or up, down, because both my x and y are 0. So if I multiply 0 by anything, I still have 0. So that means any change in period or amplitude will not affect that center point. So the first thing I like to look at is, where does that center point go? Left, right, up, down, place it there. Next, I like to look at, where do my asymptotes go? The center point is always in the center between the two asymptotes. And if we know the period of our function, we know that the asymptote has to have half of our period on one side of the center and half of the period on the other side. So if we look at this base graph, if we take a look at that center point at the origin, the asymptote to the right is half of a period over to the right. My period is pi, and the asymptote is pi over 2 the right. My other asymptote over to the left is to the left by half of a period. Again, my period is pi, so half my period is pi over 2. My asymptote is to the left by pi over 2. Once I have my asymptotes and my center point, it's much easier to graph the curve. Notice that the amplitude is not going to have a ton of effect here because we don't have a highest point on our curve and a lowest point. These go forever up and forever down. So the only thing the amplitude is going to affect is how high that next point that we drew goes. So what I mean by that is, in our picture, our other point other than the center was at a y value of 1 and -1, and it was halfway horizontally between the center point and the asymptote. So the next point we draw will always be halfway between the center and the asymptote, but the amplitude will affect how high up it goes. Our base graph, it goes up by 1. If our amplitude was, say, 5, we'd put a point halfway between 0 and the asymptote, but we would go up by 5. Okay, so this is a short set of notes today compared to 5.1 and 5.2. We're just going to do one more example together, okay? And then there's some practice questions on a worksheet that I have provided for you. So we're going to take a look here and see what we have. So we have a 2 in front. This is going to affect the amplitude. We have a minus pi over 2. So this means we are going to go to the right by pi over 2. And the -1 at the end means we're going to go down 1. Okay. There is no b value, so there is no change in period. So just a note that for tangent, the period is not 2 pi over b, it's pi over b, because our period of the base graph is pi and not 2 pi. So the first thing I would do is figure out, where is my center going to go? So my center is normally at 0, 0, but this is no longer going to be at 0, 0. It's now going to be right by 2 pi over 2, sorry, and down 1. So if I move right by pi over 2, that puts me at pi over 2. And if I move down 1, it's going to be at minus 1. I want to graph that first. So I need to figure out what I'm going to use as my scale. Because I have no change in period, and I need to move right by pi over 2, as long as I can see the pi over 2's, and as long as I can easily divide uh, by 4 again, because I'm going to have half on each side of the center for my asymptotes, and those other points I drew were halfway between that. So a common denominator between pi over 2 and being able to divide by 4 would either be 4 boxes to be a whole period, or I could do 8 boxes. So if I want to do 8 boxes, okay, then that means 8 boxes is equal to pi. Okay, so there's 2, 4, 6, 8. I'm going to have pi here. 2, 4, 6, 8. I'll have 2 pi here. I'm going to go the other direction as well. 2, 4, 6, 8. I'm going to have negative pi here. Now, I also know with tangent that I have asymptotes and I have a center point. So I need more labeled than just the end points here. I'm going to put pi over 2's in the middle of all of these. Okay. So I'm going to put my center on first. Oh, sorry, I need a y value as well. Okay. Now to determine my y labels, first I know that I have an amplitude of 2. Normally, I have an amplitude technically of 1 because my next point aside from my center is at 1 and negative 1. Since my amplitude is 2, this now means I'm going to be drawing a point at 2 and negative 2, but then I'm moving down 1. So I actually need to be able to get down to negative 3. So I'm going to put each box be worth 1. So this is going to be negative 2. I'm going to have this be negative 4. And now I'm going to put my first point on. So my first point is usually at 0, 0 in the center here. Okay. I'm not going to put it there. I'm going to move it to the right by pi over 2 and down 1. Now my label is in my way here, so I'm going to just erase my label and rewrite it above. So I'm going to move right by pi over 2 and down 1. So I'm going to put that center point. Once I have that, again, I know that my period is pi, which means I need half my period on either side of my center. Okay, so if I put half my period on either side of my center, half of my period is pi over 2. So from the center, I need to go to the right by pi over 2, and I need to go to the left by pi over 2, and then I can draw my asymptotes in here. Once I have my asymptotes, I know that my other 2 points that I need to draw are halfway between my center and my asymptote. And normally, from my basic graph, I would go halfway and go up by 1. But because my amplitude's 2, I'm going to go halfway and up by 2. Going the other direction, I'm going to go halfway and down by 2. And then I can draw. Once you have one cycle, drawing the others is very easy. From my asymptote in either direction, I know my next one is pi away because my period is pi. So my next asymptote will be at 2 pi to the right or negative pi to the left. I know that the center should be down at negative 1 and goes halfway in between the asymptotes. And the next point that I draw need to be halfway between the centers and the asymptote, and either up by 2 or halfway and down by 2. And there's 3 cycles. So you will see basically all the possible situations on that worksheet, right? Answers posted online as well for you to take a look at. And that's 5.3.